Okay, so I want to now give you a little bit more applications of this integration by parts. And I call this part 2 ILATE for a reason that I'm going to explain very shortly, but I first want to do one more example. So let's start with again reminding us of the formula. U dv is uv minus integral v du. And the purpose is that whenever we have an integral, so and here is one, I'll do this one, ln x dx. We have to match this part, u dv, with whatever we have in the integral sign, including the dx part. Now, at this point, you're going to say, wait. Now this is getting difficult, because normally don't we have two functions, like we had x sine x squared ex perhaps, but there's only one ln x. How can I split this? Well, okay, let's see what are the possibilities here. And again, there are really two possibilities, although if you think about this, there's really one possibility only. Well, we could take u to be ln x. So what would then dv be? Well, remember, it's everything else. So this would be this. Or we could take dv to be ln x dx. And then what is u? Well, whatever is left. There's nothing left. Well, okay, there's something left. There's 1. Okay, so that we sometimes have to choose a 1 there. I mean, in the first case, we basically chose a 1 here as far as this part is concerned, right? It was just dx, no other function there. So which one is the correct one? Well, now you have to look at what can we do with this. Remember, once we make a choice, so this is possibility 1, and this is possibility 2. So the question, we don't know yet which one is going to work. I'm going to explain soon how we always can make the right choice. But the one that works is 1. But I'm going to explain first what is wrong with 2 then. You say, oh, okay, wait a sec. U is 1, well, du would be then 0. That's kind of weird, right? So, okay. But this is good. I know what v is. Okay, what is v? Pause the video, think about it for 1 sec, and then you all say 1 over x. And then I tell you, go bang your head against the wall. The antiderivative of ln x is not 1 over x. That's the derivative of ln x. What is the antiderivative of ln x? Well, duh, that's the question. And we don't know yet. Okay, so be very careful. You would think, oh, the antiderivative of ln x, that's 1 over x. Don't confuse them. Don't confuse antiderivative with derivative, okay? That's a mistake sometimes people make because, yeah, it looks like it, what else could it be? So we don't know. This is just not possible. Okay, so let's work with this one then. Rather, perhaps strange choice, but okay. Once we made this choice, what is now, there are consequences to that? Well, we have to take the derivative. Du is now, what's the derivative of ln x? Okay, now you don't have to bang your head if you said 1 over x dx. That's correct. And what is v? What is v then? Well, I have to antiderive 1, that the antiderivative is x, right? That's somehow the power rule, or just simply the derivative of x is 1. So that's what you have. Okay, so now step 3, we have the formula. And the only thing that can go wrong now is that we get a bad integral, the second one, the new one. So let's see. uv minus integral v du. What do we have? uv ln x, and what is v? X. So x ln x. Write my x first. Minus v x du, and du was 1 over x dx. Okay. So now x times 1 over x dx. You can say, okay, I know I'm going to antiderive x, that's x squared, and then 1 over x. But antiderivative of 1 over x, now I'm right, it's ln x. And so we put them together. Wait, is that not the product rule? And were you supposed to do the product rule? No, there is no product rule. We cannot just integrate this and then this and put it together. That's the whole point. That's what we're doing, integration by parts. So what is it then? What do we have to do? Well, there's a very simple thing here. When you have an expression like that, you always look for simplifications. And there's a very obvious one. The x's cancel here. These x's just cancel, and you're left with 1. And that's easy. So this would be x ln x minus dx. So that is x ln x minus x plus c. And that's it. And you can very easily verify that this is the antiderivative of ln x. So be careful. The antiderivative of ln x is something that you have to work out with integration by parts. So how do we now know what to choose what? Okay, so here's another example where you might think, what is this? Arctangent of x dx. Okay, I want you to try this out, and later in the video I will solve it. But you could try it now for now. So what should you do? Which choices should you make? And work it out. Okay? So I'm going to solve it in a moment, but I want to get to this ILATE business. What do I mean with ILATE? And ILATE, don't go look it up in the dictionary. It doesn't mean anything. It's not a word. It's an acronym. It's a way of memorizing something, and it stands for the following. The I stands for inverse trig. The L stands for logarithm. A stands for algebraic. T for trig, and E for exponential. Okay, so. For instance, this is an inverse trig function. Log function, that is an ln. So this is an example of that. Algebraic functions, what do we mean by that? Well, that's powers of x, perhaps in the denominator, something like that. That's algebraic, right? Polynomials, basically. Trig functions, that was the previous examples, sine x. And exponential functions, we also saw those. Now, what does this mean now? Well, this is kind of a scale. And it's a scale where on the top is u and the bottom is dv. What do I mean with that? Well, let's look at a couple of examples. Let's look at the examples we worked out in the previous video. X sine x dx. So let's see what are they. Well, x, as I said, is an algebraic function. Okay. And what is the other guy? Sine x is a trig function. So what do I mean now? This is a scale. The highest one is the algebraic. The green one is now on top. And so this becomes u. Sorry, I should do this in the right color, right? So I'll do it here. So this is then u, and then the trig is lower than that, so this whole thing becomes dv. Okay, and the same is true for x sine x dx. X ex dx, where then instead of trig we would have exponential. But let's now look at this example that we had here, the ln x example. Okay, so I'll write it here. ln x dx. Okay, so let's analyze what we have. We have this guy here, and that is the logarithm. Oh, so, okay, we have different colors. Let me get rid of these colors here with these circles. Okay, so ln x, that is now a logarithm. Okay, and what's the rest? There were always supposed two things, right? Well, we said it was dx, remember? There's really nothing else. It's perhaps 1 times dx. And what is that? It's just an algebra. That we consider that algebraic. Okay? Constant. It's a polynomial. It's a constant polynomial. So that's why we call that algebraic. So what was now the rule? If you're on top, you become u. Okay? So the green is u. So this is now u. And if you're on the bottom, the purple one, then you dv. See? That's exactly how we chose them, right? We chose u is ln x, u is ln x, dv is dx. Okay, so this tells you how to choose it. So okay, so now we can go to the example of arctangent. Let's work that one out. Arctangent of x dx. Okay, so what is this? Again, let me get rid of my colors here. Arctangent of x, the green one, that's inverse trig, all the way on top. So definitely that's going to be u. And what is the other part? Well, again, it doesn't seem to be there. That's what we call algebraic. Okay, so this part, if you want, is the algebraic part. So the dx it's not really considered part of the function, right? But okay, so that's what we get. And so now we can work it out, right? This tells me, it's just, as I said, the green part is going to be u, the purple is going to be dv. So u is going to be arctangent x. I'm going to not switch all these colors anymore. And dv is then dx. Okay, that's step 1. Once we made this choice, we know that du is, what's the derivative of arctangent x? You can look it up, but it is something you want to kind of remember. It's 1 over 1 plus x squared dx. Don't forget to write the dx. Each time you take the du, it has to have a dx. Okay? And the driving, what is v? Well, again, that was x. So what do we get? Let's work this out. That's equal to uv minus integral v du. U is arctangent x, V is x, so perhaps I'm going to write this first. Is that okay, right? I can write it in which order I want. It's neater to write it that way. Minus V x du, this is du, 1 over 1 plus x squared dx. Again, now you might want to antiderive this and antiderive this, but no. Remember, there's no product rule. So we have to take them together and somehow solve it that way. Now, can we cancel here? Be very careful. This is a sum now. We cannot cancel within a sum. You cannot cancel the x's. Be very careful with using wrong algebra. So now this simplification didn't work. So what are we going to do here? Well, sometimes we know that we have to perhaps do it again, but no. Why is this not ILATE? Well, look, in ILATE, you have to have two different functions here. Sorry, there's something went. I lost my G of my log here. We have to have two of these things. We have to have an inverse trig, a log, an algebraic trig, or expansion and exponential. Well, we have to have two of those three, of just five. These here are both algebraic. That cannot be. They have to be different. So this is not ILATE. Now what else is there left? Substitution. That's the only way we have substitution. And once you realize that it's substitution, then it also becomes clear what we should do. Remember, substitution, we look for some inside function, and the derivative of that inside function should be everything else. So, okay, here the thing that I'm thinking about, this, right? So I'm going to use w for my substitution value, for 1 plus x squared. Why? Because dw is 2x dx. And, well, I have x dx, so I like to solve for x dx, so that I have, let me do this in different colors, so that this here matches exactly this here. Okay, and now I can plug in. The purple thing is, this x dx is dw over 2, and then the blue thing, if you want, that is this guy, is now 1 over w, right? That's now in the denominator. Okay, so now this we can antiderive. Okay, we have a 2 that we can take out. What's the antiderivative of 1 over w? You might be a little bit afraid to say it, but you're right, it's ln w, right? This is the right way. Okay, and we did the substitution. As always, we have to plug back in what w was, and w was 1 plus x squared. Now, what did I do? I solved this integral, so I should be a little bit careful. I was a little bit sloppy here, so let me make sure that we don't make this mistake here. So I'm going to erase this. What I actually calculated on the side was this integral, right? X 1 over 1 plus x squared dx. That I integrated. But there is, it comes in a formula, so now the actual answer then is x arctangent x minus, and then we have minus my result here, minus a half ln 1 plus x squared. So as I said, you have to always be careful here with these negative signs and this new integral. It's sometimes better to separately solve it and then plug in. So that's the solution. Okay, and that's the technique of ILATE. So this is the word ILATE, and once you know this word ILATE, you just look at what we have, what are the functions you have and where they go, or perhaps it doesn't fit. So I'm going to give you a couple of examples here. So, okay, so let's look at this one. I'm not going to solve all of them, but I'm going to let's figure out what they are. If at all they are something that we okay, so here are three. The first one, x squared sine x dx. X squared is algebraic, so algebraic, that is this one. Let me write my scale up. So inverse trig, then logarithm, ILATE, algebraic, ILATE, trig, and what is the last one? Exponential. Okay, so x squared, that is algebraic, and sine x, let's do it a different color, sine x is trig. So that works fine, and it's clear that this whole thing should be dv, and this thing should be u. Okay, great. X sine x squared x dx. You say x algebraic. That's algebraic. Let's do it green. Sine x squared. Now you might be saying that's trig function. That's not true. It is a trig function in which a more complicated function has been substituted. We plugged in an x squared, it has an inside function. And that we cannot allow, not at least in complicated ones like x squared. What we could allow is perhaps something like, so this is allowed, sine 2x plus 3, because that's a linear one. We can easily do a small substitution. Remember we call this auxiliary substitutions, where we replace this by w and then we are fine. So this kind of functions, they were considered trig functions. Why? Because if you would graph them, if you remember how to graph these things, but I'm not going to do that anymore, but you can look it up, it looks like a sine function. It goes up and down like a sine function. It's just the 2x plus 3 just shifts it up and left and right and stretches it out. That's what these things do. Okay? But sine x squared is not of that form. Sine x squared, if you graph sine x squared, you see it doesn't look like a sine function at all. So we should not call it a trig function. So this is, so let me make it clear what I mean to say. This is not a trig function. Not just because it says sine doesn't make it a trig function. That's my point. So what is it then? Well, it's something that does not belong to this category. So this is not ILATE. So this is not ILATE. You say, why can I not do this? Why can I not make it? So I would think this should be u, okay? I'm going to not listen to you. I'm doing u is x and dv is sine x squared dx, and then, okay, then I take derivative, du is dx, and then I have the antiderivative, and then the antiderivative of sine x squared is cosine. Is it cosine? Is it minus sine? No, it's cosine. Oh, x squared, x cubed over 3 perhaps? Now you're doing things that are not correct, right? You're integrating kind of a chain rule integration. I have no idea what that is. That's not correct, right? This is not how you integrate. If you don't believe me, take the derivative of this thing, and it's by far different from this thing. Well, not by far. It's not the same. So this cannot be antiderivative. In fact, this antiderivative problem is unsolvable. What does that now mean? Well, it means there are sometimes integral antiderivatives. We know that they exist, but we cannot write them down. There's no formula for the antiderivative of sine x squared. Now, what about this original function, the one that I gave you then? Well, what if there's only one more technique we knew, and that was in substitution. And if you think about it, substitution will work well here, right? So let me get rid a little bit of all the stuff that I wrote here, because otherwise it gets too much. So let's go back to this question now so how do you solve this one? As I said, it's not ILATE, but what you can solve it by substitution, because we have an inside function, and that was the problem. That's why we didn't have a sine function. That's why it was not a trig function, not ILATE. So it has an inside function, so we should try that, and that works because dw is 2x dx, and that's exactly what we have here, up to the factor 2. As I said, I'm not going to work this out. I want you to try it. It's not hard, so there will be homework a bit like this in the same sense. And so let's now look at the last one. I'll work that one out. Go back to our ILATE. This is algebraic. This is logarithmic, the logarithm. If you look at the scale, logarithms are above algebraic, so that logarithms, so this will be u, this will be dv. Okay, that means that u is ln x, and then dv is x cubed, which is an algebraic, right? It's the power of x. And then don't forget that dx always comes with it. So that was step 1. And so this recipe of ILATE always works. And that's why you no longer have to worry, oh, did I make the wrong choice or right choice here? Okay, so if this is u, then du is, now we know that the derivative of ln x is 1 over dx. And the derivative of v, power rule, x to the 4th over 4. That's it, right? Step 3. Well, let's see, does it work? Do we actually get a better integral? That might still sometimes be a problem, but okay, uv, ln x, this is u and this is v, so I'm going to write this one come first here, x to the 4th ln x minus v is x to the 4th over 4, and du is, where is my du? This is my du, 1 over x dx. And by now you should know what to do, right? Again, not solving them separately, but solve them first, simplify. Always, with integrals, you have to kind of prep the integral, which sometimes means the opposite of simplifying, expanding, but sometimes it means simplifying in this case. So that's easy, right? We can cancel one of the x's, and that would be x cubed then, all right? So we have to enter derive x to the fourth over 4 ln x. We have this 1/4 that I'm going to take minus 1/4, and then I have to enter derive x to the third, that's x to the fourth over 4, power rule, right? Add 1 to exponent divided by exponent plus c. And that's the answer. And if you don't believe it, just take the derivative of this function, and you'll see you get exactly the original this original function. Okay, so that is the method of ILATE, of integration by parts, but it's easier to say ILATE. And it kind of tells you how to do everything. Now, there's a couple of things that I did not cover. There are tricky ones, like for instance, when you have a combination of trig and exponential, that can be very tricky. There are also ones that are not necessarily easy to solve, even if they follow the pattern, so to speak. So in the homeworks you will see certain types you will get, and then work them, try them out, and then I will do a review. We will do a review, quiz review, and we'll also do homework review, so that we can practice this several times. Okay.